All right, so we're gonna continue to talk about SSA triangles, side-side angle, particularly when you have two sides and the angle, okay, one angle. And you notice that you have a pair here, okay? It turns out, let me see if I can move this a bit. No, I can't really. It turns out that sometimes you can't create a triangle with the information you're given. For example, I call this the fishing rod. I like fishing, so that's my analogy. This is the fishing rod, and this is the string of your fishing rod. Right now, is there a triangle? Do you see a triangle at all? Is it possible to make a triangle? We consider the ground part of the triangle. But right now, it turns out, as you can see, this string doesn't actually touch the ground. So this is an SSA scenario where you would not be able to actually compute anything. This triangle does not exist. Oh, low power mode? Yeah, sure. This triangle actually does not exist. So if I gave you a triangle where you had one side being 7 centimeters, the other one 16, and the angle 30, you would actually not, like if you tried to solve this, you would get an error at some point. The calculator would say, can't do it, this triangle does not exist. I don't want you to get to that point. I want you to be able to identify that way before that happens, okay? So let's see what we can do to actually get a triangle going here. So I'm gonna try to just, toggle it. There's one point right now where A is equal to 8 centimeters, you would actually have one triangle. What kind of triangle do you think this is? If it's straight down, this is like the height of the triangle. So you have a 90-degree angle there. So in this case, you actually have one triangle possible. If you have your calculators with you, on you, let's calculate the height of this triangle. Do you remember a shortcut for height of a triangle? Slant times sine of the angle adjacent to it. So try that. 16 times sine of 30. What do you get? 8. So if that string that was dangling earlier is exactly equal to 8, that represents the exact height of this. Like if I were to extend this to 16 centimeters and then measure the height to the ground, we know it's 8. So if this side, the string, is 8, you have a perfect right triangle at this point. So one triangle possible. But what if this string is a little bit longer than 8? What if I extended this to 9, let's say? What in the world is going on there? How many triangles are possible now? Well, there's one right here, this one, okay? And then there's one, let me stop the swing there. There's one out here, like if this string swings out here, you could be talking about a triangle that is like this. Let's keep swinging. Or you could be talking about this triangle. And you're like, what in the world? Like, why is this happening? Like, why are we talking about this right now? I don't know if you saw me write down the ambiguous case of the sine law. Let's talk about that for real. The title of this lesson is called the ambiguous case of the sine law. And so every time you have an SSA triangle, you need to consider the ambiguous case. What does ambiguous mean? What does ambiguous mean in English? It means you're not quite clear, right? If somebody's ambiguous, they're not being clear enough to you. Like, what do you really mean with that? That's why we call this case the ambiguous case of the sine law. Only sine law has a problem with knowing how many triangles are possible. Only sine law. And before you panic, you will know, I'm not just going to randomly throw this at you. When you do a quiz or a test, I'm going to actually say, hey, how many triangles are possible here? That's the only time I want you to like worry about this scenario when I ask you for it. But you'll know that it's the SSA scenario, the SSA case. If it's SSS, do you need to worry about it? No, it's cosine law. If it's SAS, the angle is in between the two sides that you're given, don't worry about it. It's never going to be an issue. The only time is when it's side-side angle. When you have a pair and another angle, then you need to worry about it, okay? So again, I'll show you here one more time that the string is always across the angle that I give you. Let's keep swinging that, right? So that string is the main character in this whole play. We need to look at what's happening to the string compared to everything else. And so that's what we're going to do today. So if the string is a bit shorter, if the string gets too short, you don't have a triangle. It's just not possible. So I'm gonna give you tools to identify this. Okay? If the string is longer, you've got potentially two triangles. But if the string is too long, watch this. If it's longer than 16, we actually consider only one triangle possible. Okay, number of triangles 1. So I will dive into the lesson now. I just thought I'd give you this visual here. I might come back to it, but let's go back to our notes and fill in our notes. Okay. So, so when you have an SSA scenario where the given angle is acute, right? If it's SSA and acute, we will force our diagram to look like this. Okay, where you have. Let me give you one more tip here. How do you know it's SSA? You've got a pair plus one side. That's how you know it's SSA. You've got a pair and another side. So example, let's say I give you angle A is 40 degrees, side A is 3 centimeters, B is 5 centimeters. There you have your pair, okay? You have your pair and another side. Okay, and then you know, okay, this is SSA. Okay, this is SSA, I need to be extra careful here. Okay, so let's see what happens. I always want you to, when you recognize that it's SSA, I want you to put the side and the angle. This is your pair. Okay, I'm going to actually write this down. This is your pair. You're going to have them across from each other. No matter what, you're going to put the angle that you are given here, and the string will be across from it. Okay? So given angle goes here, and then you've got the side that is across from it over here. We call that the string. Okay? We call that the string. And the other side is the rod, the fishing rod. Okay? So now let's ask, okay? I want you to, the first question to ask, once you've done your diagram, guys, we're always going to do this little sketch here when we're trying to figure out how many triangles are possible. We're going to ask, is the string greater than or equal to the rod? If you can say that the answer is yes, right, then you've got one possible solution, or one possible triangle. Either way is fine. Okay? This is your conclusion. Okay? and I will add something. No need for height. No need for the height there. Can I just tell you something? Up until this point, I always made sure that the answer was yes, so we only had one solution. So whenever you had an SSA, I just made sure that this is what happened. Okay? But now, if the answer had been no, like if you say, is this string greater than or equal to the rod? And if the answer is no, then you need to keep investigating a little further. You need to find the height. Height is equal to rod, in this case, because that's going to be your slant, right? Times sine of the angle. I will use x because my diagram has x, okay? The angle given here is x, so I'm actually going to go sine of x. And I'm going to use a color for this, because some students miss this. So the height, this height, okay, is essentially going back to our sketch, and we're going to figure out what is that distance from the peak to the bottom of this sketch. And now, remember, in every single one of these cases, you've determined that the string is now shorter than the rod. And now we have three options. Three options that result from this. The string could be shorter than the height, or the string can be equal to the height, or the string could be greater than the height. Those are your three outcomes there. If the string is shorter than the height, this is our scenario here. Right, this is your rod. This is the height. That's the rod, that's the height. And your string, I'm going to use a color for it. Let's make it go a little bit at an angle like this. Your string is just never going to make, like if this string here, if this string is shorter than the height that you've calculated, you're just never going to have a triangle. Okay? No solution. So if your string is shorter than the rod, and you further determine that the string is shorter than the height, this is the case where the string is just going to be dangling there. You're not able to actually produce a triangle. So your answer is no solution here. Okay? If the string is exactly equal to the height, what do we have? If the string is exactly equal to the height, we have a right triangle. We have one solution. Okay? So we're going to draw this and make the base dashed because we technically don't know what it is in terms of, but this is where the string is equal to the height. We've got one solution. This is actually a right triangle, to be specific. By the way, I can say you can also answer there's one triangle or one solution. Both are acceptable. I just don't want to fill it up too much because then it gets too busy. I will give you a cheat to add to your study sheet. Like, it's going to be a lot less going on, but you first need to see the whole thing before you get that little shortcut, okay? And the last scenario, when the string is greater than the height, this is our problem here. This is the most work intensive. This one right here. You have two triangles. If the string is greater than the height, you've got this scenario going on. So I'm going to actually first do my sketch. Okay, and I'm going to use my red pen here. You still have the height going on here. This is still your height. And you got to understand here, once you copy this part, you got to understand what's happening here. This string is longer than the actual height of this resulting triangle. It's longer. So it's going to swing over here. That's triangle number one. Or it's going to swing over outside here. And I have to be careful with triangle number two. I don't want to put a 2 in there. Because some students think that this is the other triangle that is formed. That's not true. Remember, this rod is part of your triangle for sure. This string swings over here, creating one triangle there. Then it swings out. And remember, the string makes a triangle with the rod. You have your second triangle out here. So now I'm going to branch off into those two, okay? So you've got number one and number two. You've got this scenario. And remember, this is just a sketch. You don't have to have it look exactly. And you've got this one here. If you have a color, try to just tell yourself this is the string. If you don't have a color, just write down string is out there. So the string is our main character here. It's always like string compared to the other. String compared to the other. That's what we're always doing here. So hold on, we haven't answered this. There's two solutions. So, Mr. Dixon, are you telling me that if this is the case, I have to solve two triangles? I have to solve two? Yes. We're going to have to consider both cases. This is the ambiguous case right here in the making. This is where there could be two possible answers. Okay? So we're almost done. This is the justification at the end of please understand this. I will zoom out for this, okay? There are four possible conclusions you can make. 1, 2, 3, 4. Okay, there's four. You can't land on this and that one. Like, you can't land on two conclusions. It's only one of the four, okay, that you can land on. So I want you to always have a justification for each one of these here. So for all of these, this string has always been shorter than the rod. That is number one. So write that down. For each of these cases, we've identified that the string is shorter than the rod. In this particular case, though, we also determined that the string is less than the height. This is the justification. In this case, we determined that the string is exactly equal to the height. And in this case, we determine that string is greater than the height. Huh? Right? I know. But remember, each one of these we've determined that the string is shorter than the rod. Then we had to find the height and analyze a little further. Okay. By the way, all of this, we dealt with an acute angle that we were given. Now we need to deal with the obtuse, which is on the other page, on 104. Much easier, much easier. Go to 104. Highlight that there's no need to find the height, because some students still proceed to find the height of this one. No need. Make sure you make a little arc here, and you make a note that this would be an obtuse triangle. This is when you caught a fish, right? You caught a fish, now you're pulling the rod back, and there's a string there, okay? There's only two possible outcomes there. If the string is greater than the rod, you've got one solution. If the string is less than or equal to the rod, guess what's going to happen then? If the string is less than or equal to the rod, no solution. Those are your only two options. Yeah. Okay, so now let's put it into practice. Okay, let's see what can we do here with this.
Excuse the interruption. Unity Goodmanson, please go to room 61. Unity Goodmanson to room 61.
I don't give you diagrams, but just imagine for a minute that the string is less than or equal to the rod. If this is exactly equal to the rod, guess what? If you imagine this swinging, you're not going to get another triangle. It's not going to make contact anywhere else. If this is shorter than the rod, if it's somewhere here, you're most definitely not going to get a triangle. It's just going to dangle there. So always imagine the string kind of swinging and see maybe if you can visualize it that way. Let's continue here.
Please contact the office. Ambiguous, you can go to the office, please.
Okay, I'm going to get you started, and then I want you to practice this a little bit. What is the first question you're going to ask? You're going to compare the string and the rod. I already labeled it for you. You're going to have to do that down the road, okay? What can we conclude about between the string and the rod, just looking at the numbers? What can we conclude? That the string is shorter than the rod, correct? That's step number one. If the string is shorter than the rod, I'm going to take you back to 103. If the string is shorter than the rod, then you have to compare the string to the height now. Okay? Now you have to compare the string to the height and see what happens. I already calculated the height for you, so you don't need to do this part. You just need to tell me in which of these three camps do we fall. Okay, let's go up here. We're gonna now compare the string and the height. What do we know about the string and the height if we compare the string and the height? The string is shorter than the height numerically, right? Therefore, no solution. Oh, you know what? Can I erase this? I feel like you're still newbies. So what I'm going to do is string shorter than the rod. I'm just going to show you that 3 is less than 8. Okay, that's what we're comparing here. And the string is less than 5, right? String and height. You don't have to do this down the road, right? But therefore, no solution. Okay, there you go. Let's do one more here. This is string. Sorry. Get your act together, right? Rod and string. This is the height. So let's compare the rod and the string first. The string is less than the rod. That's conclusion number 1. Which means now you need to compare the string and the height. What can we conclude about the string and the height? It is less again. Okay? Therefore, no solution. I'm going to ask you to try these 3 right now. As you should have a string and rod for sure comparison, and then string and height perhaps. Okay? Can you do that for all of these here? Just these 3 right here. Do what I just did to the best of your ability, and I'll go over it. I just need you to get your brains engaged with that a little bit. All right. Take it over again. So I would encourage you to at least put R and S there. I don't want you to just use R and S unless you've labeled it on your diagram. H, right? So rod, string, height. Rod, string, height. You're going to take it up a notch after this, okay? So the first thing is you compare your rod and your string. Imagine the height isn't even there yet at first. You're going to have to calculate that. Okay, so string and rod. I noticed that the string is shorter than the rod. Okay, I have to keep investigating. String and height. I noticed that the numbers are exactly the same. And you're like, Mr. Dixon, why do you make this shorter? Like, why is that like that? Because this is just like a triage tool. We're not drawing this to scale. We're just making sure that the sides are where we want them to be. And so we only have the numbers to go off of. So in this case, you've got one triangle, one solution. This is actually a right triangle. If you identify that, that is even better. I would be content with just one solution at this point. Next, this one is going to take some of you by surprise, perhaps, because we've been talking about string rod. Let's do that first. String and rod. What do you notice about the string compared to the rod? It's actually greater. One solution. Okay? You don't need to check the height. If you notice that the string is greater than the rod, you're done. No need for the height. It's that very first case, if you allow me to just go into your notes. If the string is greater or equal to, either cases work. You're done. One possible solution. No need to find the height. Okay, so I'm going to say this. If you did compare the height, it's not the end of the world. You're actually not wrong, but there's no need to find the height. There's no need for it. So one solution, no need for height. If you need to write that down in your notes under that case, when I go sideways, I did say no need to find a height in your notes, but if you want to highlight that, go for it. Next, string and rod. I notice that the string is shorter than my rod. Then I have to go string and height. I notice that the string is greater than the height. This is the case where you have 2 solutions. Okay? So there we go. These were all acute examples. What about obtuse? I will make a note here, obtuse. Obtuse, okay? So when you have it drawn like this, all you care about is the rod and the string. What about the height, Mr. Dirksen? Why is it there? To just try to tell you that you could find the height, but it's not necessary. So rod, string, height. So I'm just going to compare string and rod. I notice that the string is slightly bigger than the rod, therefore one solution. Here, I notice that the string is less than the rod, so no solution. That's it. Okay? No need for heights. No need for height. I'm going to write that down and give it an arrow pointing to both cases because it's obtuse. Okay? The reason is it's because these are obtuse cases. We don't need to worry about the height, period. Okay? Fun stuff, eh? Yes, fun stuff. Anyways, just so you know, this unit is exactly the same in pre-cal. Trig is exactly the same. They do everything we do here in pre-cal 11, okay? So if you're interested in challenging pre-cal after you've done applied, this is one of the units that you'll be like, oh yeah, I got this, right? I've seen this before. Let's go to 106 here. So this is what I would expect you to know how to do moving forward, okay? If it's an SSA case, so determine if is it an SSA case. How do you determine that, guys? Do you remember? Find a pair and another side, then it's SSA. And then I ask you how many solutions are possible, justify. Guys, if you see that kind of wording, that's the only time that I want you to like engage with this stuff. Okay, when I ask you how many solutions are possible, I'm not just gonna throw that at you from like out of nowhere, okay? I'm gonna tell you how many solutions are possible. You're thinking right away, oh, the rod string thing, got it, right? So here we go. ABC has angle A and side A, so that's a pair. And another side. Pair and a side is definitely SSA. So here you have to do the rod and the string. Mr. Dirksen, what if it's not SSA? What if it's SSS? One triangle. Morning. Page 106. Okay. It's SSA, you have to check. If it's not SSA, don't worry about it. Okay? Next, I want to narrow this down even more. It's acute. It's SSA, it's acute. You haven't caught anything yet. Okay, so I force my diagram to look like this. I go dash down here. And the only angle that I'm given, that 37 degrees, is going to go over here, which means that angle A goes on this corner right there. Which means side A is going to be across from it. And guess what? Where's that other side going to go? Exactly where we've been putting numbers all the time. We're going to make that our rod. Okay? This is our rod. Okay, so this is B, which means that if there's a triangle possible, where's angle B situated? It's going to be here, right? If we can make a triangle, it's going to be across that angle, but we don't know yet. So can you please make sure you go string and rod? Okay, make sure you have that determined, and we're going to check. Let's go on our journey. String and rod. What do we notice about the numbers? String is greater than the rod. One solution. Do I need to find the height? I don't. String. So this is the one you like the most. String is bigger than the rod. Let's go one solution. Okay? One more. I noticed that we've got a pair plus a side. That's SSA, okay? In particular, acute or obtuse? It's obtuse, correct? So I'm narrowing it down even more. So I want you to do this, right? It's going to look like this. This is my string. Technically, the bottom, I like to have the base dashed. Okay. So guess what? The 127, which is angle Y, is going to go in this corner here. 25 centimeters is going to go over here. This is side Y. And the other side is going to be going over here, which is side Z, right? This is my string, and this is the rod. Now let's compare them. String compared to the rod. What do you notice in terms of the numbers? This string is shorter than the rod. Therefore, how many solutions? No solution, right? No solution. You will notice that my key sometimes says no triangle. That's the same thing, right? One solution, one triangle. Can you try the other one by yourselves? Try DEF. Make a nice sketch first, and then make your conclusion. So you notice that there's side F, angle F, that's your pair. And you've got a side here, okay? Pair and a side, you know this is SSA. And it's acute because of the 75 degree, okay? So you know that this is the case that looks like this. The angle that you're given is 75. Make sure you put F across from it. The other side therefore goes here. This is my rod, this is my string. Okay, make sure you label it that way. So let's go through the triage, right? The string, although not by much, is shorter than the rod. Now we got to compare the string and the height. Wait a minute, height? There's no height, Mr. Erickson. You can find it, right? Height is going to be 9.7 times sine of 75 degrees. Let's figure out what that is. I don't have the key in front of me. Let me see. Oh yeah, 9.37. So if you get to this part, you want to calculate this. I want to highlight this here. So now we actually calculate what the height is of this triangle to see what's possible now. And you got to look at the string and the height now, and you realize that the string is greater than the height. So this is your justification coming to your final conclusion. So this would all be part of showing your work. Okay, your diagram, telling me how are you comparing string and the rod, as well as the calculation of your height. So in this case, there are two solutions. Okay. We know that the string is longer than the height, so we'll swing in here and it will swing out. So we're going to form our two triangles here. Okay. All right. So for you, I'm going to ask you to do 107. You know what? I'm going to take it a little further. 107 and 108. 108 is a little different, but I'm curious to see how you deal with that. Okay, that's it for this part.